All right, welcome. So I'm going to ask you to take a moment and actually complete the do now for yourself, and you can actually check the answer key for that on your own. Right now with you, I'm going to take a look through example 1, and hopefully you see that it's a minor extension of some of the work that we've done previously. So here we have a function f of x is x squared minus 9 over 2. And if we go ahead and take a moment and actually factor that, some of the information about the graph we can immediately acquire from that factored form is that we're going to have x-intercepts when that numerator is equal to 0. So the x-intercepts will be occurring at -3 and 3. We can also see that x equals -2 is a vertical asymptote, and we have no holes because we have no cancelling factors. What's a little bit more challenging to acquire is the end behavior. So we've got these tables here, and as we take a closer look at these tables, we can see that on the right hand side, as x gets progressively larger, so too does the function. And at the algebra 2 level, you guys would have probably said as x tends towards positive infinity, the function is tending towards positive infinity. Likewise, on the left-hand side, as x gets progressively more negative, the function itself gets progressively more negative, and we might represent the end behavior in this way. Our objective today is to say, look, can we actually be a little bit more detailed than just saying the y-coordinate is tending to positive or negative infinity? We can clearly see that there is no horizontal asymptote because it's not tending towards some finite value. So what is going on? Division is going to help us out. So if we take a moment and we actually take our function x squared plus 0x minus 9, I'm just going to write it like that, and divide it through by x plus 2, we can get the function in a different format, and that will allow us to analyze the end behavior in a more detailed manner. So certainly if we perform the division, we can see that we've got here repeated subtraction, and so we're going to get -2x minus 9 minus 2 would give us -2x minus 4, and so we get a remainder here of -5, and what that tells us is that another way of writing this function is to say f of x is x minus 2 minus a remainder of 5 that still needs to be divided by x plus 2. So this is the proper rational form. And when you're converting into proper rational form, as you probably remember from last class, this quotient of x here gives you your end behavior. And what we're going to see today is that this piece right here gives you your orientation relative to that end behavior. I'm going to be a little bit more detailed on that. So normally, end behavior describes what's going on as x tends towards positive or negative infinity. So if we want to look at the extreme right, we're going to analyze the limit as x tends towards positive infinity. And what we can see as x tends towards positive infinity, well, yes, from the table of values we can see that the y-coordinate gets bigger, but actually, if we have a look at that table of values again, and we just sort of take a closer look here, you can see that this is kind of approximately 10 minus 2, that this is approximately 100 minus 2, approximately 1,000 minus 2, and that this is approximately 10,000 minus 2, i.e. at the extreme ends we have f of x is approximately x minus 2. That, of course, is the quotient when we convert to proper rational form. So if we wanted to analyze our limit a little bit better, what we can say is that the limit as x tends towards positive infinity, well, the function approaches x minus 2, and we can now go ahead and just take a look at this other piece right here and say, okay, well look, if I was to plug infinity into that, negative 5 over infinity plus 2 is approximately 0, but it will be negative. It will just be underneath. And so as a result, our limit is pretty close to the line x minus 2, but we're going to be just underneath. We do the same sort of thing when analysing the limit as x tends towards negative infinity. Our function is still going to approach the line x minus 2, but if you go ahead now and plug in negative infinity, negative 5 over negative infinity plus 2, well, that's basically negative 5 over negative infinity, which is basically a positive number that's incredibly tiny, so 0 plus. And that tells us that we're going to be just above that diagonal asymptote. So what have we acquired here? Well, our quotient was the line y equals x minus 2, and by analysing the limits we say, look, at the extreme ends the function is actually going to approach the line x minus 2. We already knew that the function was going to have a vertical asymptote at x equals negative 2. We also knew, as we were beginning to piece things together, that it would have an x-intercept at negative 3 and at positive 3. And if we looked a little closely here, we could plug in 0 and analyse that actually f of 0 here is going to give us negative 9 over 2 as a y-intercept. So we know that negative 4.5 is our y-intercept. Reminding ourselves of these limits, this proper rational form tells us that at the extreme ends, the graph is going to look like the line x minus 2. On the right-hand side, we're going to be underneath. So we're going to go ahead and add that information to our graph. And as we take a closer look here, on the left-hand side, we're told that we're going to be above. So now what we've got to do is we've got to piece that information together and work from the end behavior in. So if we know that we've got to pass through here, pass through here, pass through here, and at a vertical asymptote we either shoot up or shoot down, shooting down is our only option. Likewise, if we've got to pass through that x-intercept and then either shoot up or shoot down, shooting up is our only option. And so this function takes on the form of this shape here. We say that the line y equals x minus 2 is a slant asymptote. You can call it an oblique asymptote, sometimes referred to as a diagonal asymptote. And we've already talked about those limits. The limit as x tends towards negative infinity, well, we approach the line x minus 2, but we're just above it. And on the right-hand side, we approach the line x minus 2, but we're just below it. And so we've already gone ahead and used the limits to determine which way we approach. Again, we're just using our number sense there, just like we did in the lesson on horizontal asymptotes. And that's really it for today. So I'm going to ask you to sort of use the same sort of approaches, work together, and see if you can go ahead and tackle the next few examples. Certainly when you approach example D, notice that you've got a degree 4 divided by a degree 2. Think about what the quotient's going to look like, and that will help you to understand what the end behavior will look like. But aside from that, there aren't too many tricky questions here. Obviously use the answer key to help you out, and we'll take some more time next class to go through anything that you have issues with.